Alright, this is the video that I've tried now 4 times to upload, and I've also tried, this is my 3rd time trying to make it, just because it seems like it's a difficult concept, but it's not once you realize what's going on. So I'm going to try and simplify it the best I can. So let's look at our 4 functions. These are the parent functions, okay? F of x is just some number. It doesn't have to be 1. It could be 1, 2, 3, 4, -1, -2. That's a constant. Y is always the same thing. Remember, this f of x just means y equals 1. Y is always 1. That's how it looks. Then we have our linear function. Linear function, in this case, they've given as an example the parent function, which is y equals 1x. Remember, this is y equals mx plus b. So there's no b shown, there's no plus something, so the y-intercept is 0, since b does not exist. The slope is up 1 over 1, up 1 over 1. Our absolute value function. Absolute value functions are a piece of cake. I'm going to show you really quickly how to generate points for it. Y equals absolute value x. If x is 0, the absolute value of 0 is 0. That's this point right there. If x is 1, the absolute value of 1 is 1. 1, 1. If x is 2, the absolute value of 2 is 2. If you plug in -1, the absolute value of -1 is 1. And same thing with -2. So it just makes that nice V shape. And likewise, our quadratic function, y equals x squared. If you were to generate points for this, 0 gives you 0, 0 squared is 0, 1 squared is 1, 2 squared is 4, -1 squared is 1, and -2 squared. -2 times -2 is 4, so that's 0, 0, 1, 1, 2, 4. So it starts to grow pretty darn quickly, and then you get matching points on the other side. So we can use a function, and we can generate points really, really quickly for it just by substitution and then evaluating. So let's look at today's stuff. Today we are going to do transformations of these functions. Now, you can brute force graph these functions like I just basically did by making a whole list of points, and once you've made that entire list of points, you can just graph those points and you have a very good idea of what the graph looks like. However, there are quicker ways to skin this cat, and let me show you what I mean. Let's say I want my graph to transform by moving up or left. Here's how you do it. I could use, and I'm going to use the quadratic one because I think it's easier to see. Let's say I want to move my graph up by 1. Well, what does that do to the equation? It just adds 1 to it. It would be the identical graph, just shifted up by 1. In fact, maybe I can show this a little bit better. X squared plus 1 would be the same graph, but if I can grab this guy, it's not going to let me grab him. Darn it. Be the exact same graph, just shifted up by 1 unit. If I want to translate that graph downward, maybe I want, instead of moving up by 1, I want him to translate down by 5. Fine. Subtract 5. 1, 2, 3, 4, 5. Same graph, just down 5. Let's do the same thing now to the absolute value function. If I wanted the absolute value function to move up by 1, all I have to do is add 1 on the outside, and I've just translated him. I've slid him up by 1. So a number on the outside of the function moves it up or down. You can do the same thing with a linear function here. If I were to add 1 to him, it'd be the same graph, except it would be translated up by 1 unit. If I want to move him down by 10, I can do minus 10. It'd be the same graph, just slid down by 10. And the same thing with this constant function here. If I were to add 1 to him, he'd go up by 1 unit, be it y equals 2. Or if I said minus 5, he'd go down by 5 units. He'd be at negative 4, somewhere down there. So to translate a function up and down, you just have to add or subtract a number outside of the function. The other form of translation is left and right. Well, how do we do left and right? In this case, you have to do it inside of the function. So this one, for example, would be slid to the right by 3. Now, I know I put a minus 3 in here. What you want to ask yourself every single time is what makes this 0 inside. A positive 3 makes it 0, and that means it would be slid to the right by 3. So 1, 2, 3 would be exactly the same graph, but it would be moved to the right by 3. If I want to slide it left, I'm not going to use subtraction, I'll use addition. See if we can get this all erased. I'm going to slide it left now. F of x equals x, and we'll do plus 4. And again, I ask myself what makes this 0 in here, and that's negative 4. That means this graph would be slid to the left by 4 units, but it would have exactly the same shape. It should be more parabolic than I drew it. Absolute value functions. Let's move that guy left and right. If I have an absolute value function, I want to move it left and right. Let's move it right by 2 units. Inside the absolute value part of the function, I put negative 2. What makes that 0? A 2 would make that 0. So if I were to graph this, it would move it 2 units to the right, but it would look exactly the same. So that's a translation of 2 units to the right. It's harder to demonstrate this with linear and constant functions. A constant function would look exactly the same. In fact, you can't even really shift it left and right. You can only shift it up and down. And a linear function, shifting left and right, could also be conceived as a shift up and down. So we generally don't talk about translations left and right with those other 2 functions. So that's the first thing. We can move a function up and down by adding or subtracting the number. And we can move it left and right by adding or subtracting, but with the inside the function part. So if it's absolute value, it has to be inside the absolute values to move it left and right. Same thing with the quadratic function. It has to be inside the x squared part to move it left and right. Outside it moves it up and down. The next thing we'll talk about is reflections. Reflections are when you flip something over an axis or some other line, picked at random. What we're going to focus on is reflecting across the x-axis, and that means take, and again the parabola is a great way to start, take a parabola that's right side up, and we're going to try to flip it upside down. Really easy to do. All you have to do to flip it is put a negative sign in front of it. like so. And what that causes to happen is every time you plug in an x, you get out a y, but then it changes the y to the opposite sign, which puts it in that bottom half of the coordinate axis. So a negative sign out front will flip it upside down or reflect it across the x-axis. Same thing goes with the absolute value function. If I put a negative out in front of it, it's going to take it and it will flip it or reflect it across the x-axis. If I were to do that to this linear function, watch what happens. This is more curious. Every single positive x becomes negative, so it flips it across that x-axis. So the point like up here will become the point down there, and vice versa. And the same thing happens with our linear function. Okay, if I were to put a negative in front of that x, it becomes -1, which would be down here, and it's flipped across this x-axis right there. That should give you a good feel for it. I know we're going to have questions tomorrow in our classroom about the homework on big ideas, but that's all right. Questions are good.